So this is going to be another example of a biconditional derivation. It's not from the homework, but if you update your logic program, you will find it in the logic program list. It's a new problem, so you do need to update the list, but once you do, you'll find it there, and I think you'll find it helpful to follow along, because this is going to illustrate the basic strategy for working with biconditionals. The sort of the biggest strategy. We haven't yet used the biggest strategy, and it covers all of the cases. It will work in all the cases that you need it to. Okay, so we start with show the conclusion, and it's the biconditional P if and only if Q. Any assumption to be made? No, because we're not trying to show a conditional. So we'll say premise 1 and premise 2. And now we look kind of stuck, right? Can't do anything with 2 or 3. So we think, okay, well, how are we going to finish? We're going to finish with direct derivation because we're not trying to show a conditional. And that means we're going to apply dd to P if and only if Q to box and cancel line 1. How do we get the biconditional? Well, we use the rule CB, and what do we apply the rule CB to? We apply it to if P then Q, and if Q then P. So this line of reasoning tells us what we want. We want both of these conditionals. We need both of them. When we have them, though, we'll apply CB, which will give us P if and only if Q, to which we will apply DD to box and cancel the entire derivation. So those are the two conditionals that we want. In the previous examples, we always had one. In this situation, we don't. We don't have either of them. So we're going to have to do two subderivations. So we'll say show conditional, and let's just do if P then Q first. It doesn't matter. If you're going to do both of them, the order doesn't matter because they're done separately, as you'll see. So we say show conditional. Okay, we'll go ahead and make an assumption of P as an assumption for conditional derivation, and we want to see now if we can use P. So we look back at 2 and 3, and as it stands, by itself we cannot use P. For modus ponens with 3, we need negation P, but that's not what we have on line 5. For line 2, for MP, we would need not Q. For MT, we need negation P. Okay, we don't have negation P, we only have P, but we can apply double negation, the rule, and we'll get negation P. And we can apply now MT to line 2 and 6, because 6 is the negation of the consequent of line 2, which gives us the negation of the antecedent, negation Q. What should we do with that? Well, we're trying to show if P then Q, so we would like to get Q, because then we can box and cancel line 4 with CD, and we can get Q by removing the double negations from line 7 by eliminating them, and we say 8 CD. Okay, good, so we got if P then Q. Now note, this subderivation is now completed. It's over. We're not inside of it anymore. Well, what's happened is we've just gotten this. We got if P then Q. But now we need two things to complete this derivation. We need two things to apply CB to give us P if and only if Q to allow us to do direct derivation. We also need if Q then P. So now we're going to do that. And we'll give the same shortcut command here, show CUND, because these are the two conditionals that make up the line we're trying to show. So, okay, we want to show if Q then P. Well, we'll say, okay, assume CD gives us Q. Can we use Q? Well, not as it stands with 2 or 3. For MP with line 2, we need negation Q, and for MT, we would need negation P. We don't have either of those. For MP with line 3, we need negation P. For MT with line 3, we need negation Q. Okay, we don't have negation Q, but we can get it with DN applied to line 11. Now we can apply MT to line 12 and line 3, and we'll get negation P. Lo and behold, we're almost done, because we want P, which we can get by removing the double negations, and we have our conditional derivation of line 10. Now that that's done, we can use both of these. We can use if P then Q and if Q then P. And what will we want to do with them? We would want to put them together with CB to get the conclusion. And now we can apply direct derivation, and we're done. Okay? So, to get the biconditional, we get both of the conditionals, and we do them separately. We're separately deriving two different claims and then putting them together only at the very end. So we have two subderivations. So this is actually what, in general, a biconditional or a derivation of a biconditional will look like. It will look like this. Maybe there are premises here, but whatever. Oh, who knows what the premises are? And then We'll do the derivation of one conditional, and then we'll do a derivation of the other conditional, and then we'll put them together with CB, and then we will apply direct derivation. Okay, so this is the general format of what a derivation of a biconditional looks like, and the strategy you want to approach. Show the conclusion, bring in your premises, and then you do two separate subderivations. You do the subderivation of the conditional going from left to right, and then you do the subderivation of the conditional going from right to left. So left to right if x then y, right to left if y then x. And you can use the show cond command to enter both of these show lines. Okay, so that is how you approach in the most general case, trying to do a derivation of a biconditional. You do a subderivation of each of the component conditionals, and this is what it will look like. What's going to happen in here? How are you going to show if x then y? How are you going to show if y then x? Who knows? That depends upon the details of the derivation. And we'll go ahead and do another example, the last homework example. But this is what it should look like in general. There was only one derivation for the homework where you had to do both of these subderivations, but that's in general how it looks. Okay, so I'm going to go ahead and save this problem and then move on to the last homework problem.